In this problem, we're taking a look at a book and we're trying to minimize the perimeter, make it as small as possible while keeping the area at 21 square inches, possibly so that we could fit in all the text. So some formulas that might become handy when we think about rectangular shapes and areas and perimeters are area. And area is length times width. So I'll call L length and I'll call W width. And we know that the area is going to be 21. So I'll just go ahead and put in a 21 there because we already know that. Now perimeter is the distance all the way around. So we know that we have two lengths and we have two widths. These have to be the same length and these have to be the same width, or else they wouldn't be a rectangular book, and that would probably just be strange. So perimeter is equal to 2 lengths plus 2 widths. Okay, well, we know that we want the area to be 21 inches. So this is really a constraint. This is something that has to happen. So let's take a look at a couple of examples. So what I'll do is consider because we're going to want to write an equation for the perimeter as a function of the length. Now we know that the perimeter depends on both the length and the width. So we'll start here. So length and width. And if the length of the book is, say, 7 inches, then the width has to be 3 inches. Because keep in mind that 7 times 3 is 21, and 21 square inches is how the area of each page of the book, and that's what it must be. So in that case, it would be, perimeter would be twice 7 plus 2 times 3, which would give us 14 plus 6, which is 20 inches of total material of distance around the book. So basically this book would be a fairly small book. However, it may not be the smallest book I can create. Well, what are the other options? Well, I could do, let's see, a length of 4. And if I did a length of, let's do this. Let's keep the numbers nice and pretty. If I did a length of 21. Okay, so this is a really long book. It would have to be really, really skinny. It would have to be 1 inch because, again, 21 times 1 would be 21 square inches. Well, how much would that use up? Well, it would have to use up 2 lengths plus 2 widths, and the perimeter would be 42 plus 4. That would be 46 inches total. So that's obviously a book that is very large, and as demonstrated by the perimeter, has the same area, but probably would be a very strange book to read. Well, then we have the off-kilter dimensions too. Let's say we have a book that is, I don't know, maybe 8 inches, or let's do this. Maybe the book is 10.5 inches. Well, how do we get the corresponding width for that? Well, if area is 21 and length is 10.5, then I should be able to take 21, divide it by 10.5, and that should tell me what the remaining dimension should be, which would be 2 in this case, because 2 times 10.5 should give me the area of 21 square inches. So now I would have dimensions of 2 10.5s plus 2 2s for a total of 21 plus 4 would be 25 inches of material. So still a little bit bigger so far. It seems like this might be the ideal dimension, but we could keep on doing this. But in essence, what are we doing? Well, we're taking the length into the perimeter. So our perimeter equals twice our length. Now we didn't do anything with that length. That's what we decided to select random numbers for. But now we don't want to have 2w in here because we want to make sure our equation is only related to the length. Okay, well, how do I get the width from the length? Well, I took the total area, which is 21. So I'm taking 2 times the width, which is 21, divided by the length itself, right? Because in order to get the width, I had to divide the area by the length. So this number here is basically my 2 here. This quantity here is basically my 1, because if I take 21 divided by 21, that leaves 1 for the width. If If I take 21 divided by 7, that leaves 3 for the width. So that's basically what we did. Now it's only in a symbolic form. Okay, so that's what we have. And so 2 length plus 2 times 21 over the length. And I'm going to simplify this a little bit. So I have 2 times the length plus 2 times 21 is 42 over the length. And now I'm basically have my perimeter function that is only based on or determined by the length itself. Now this guy here is really just the width, but notice there's no W in there. That's the beauty of it. I only have one variable on the right and one variable on the left. So now I'm back to the idea of just one input and one output. So this is part A. There's our answer. Part B, we want to find and interpret P of 6. So that was a really hard part. So P of 6 would say, well, hey, wait a minute. Here's my P function. My P function depends on L. So if I do P of 6, that must mean I plug in 6 for the length and plus 42 divided by 6 for the length there. And so now I can take 12, and I guess we can do this by hand. 12 plus 42 divided by 6 is 7, so I have a total perimeter of 19. Well, look at that. That seems great. That's actually a smaller perimeter, and I get the same area than any of the 3 that we chose in our table. So at some point there must be a best length so that I minimize the perimeter of the book, or minimize the dimensions of the book. I keep jumping around here. I think I want to go back a couple pages. So in part C, we want to find and interpret P prime of 6. Before we do that, we have to remember P is our output. That's a perimeter in inches. L is the length in inches. So P prime would have units of change in output over change in input. So our output is inches of perimeter per inches of length, or per inch of length. So this would tell me that what would my increase in perimeter be if I increased 1 inch in the length? Now you might say that, oh well duh, that would just be 1 inch in the perimeter. However, that's not necessarily the case. So let's take a look at this guy. I want to find P prime of T, or P prime of L first, and I know that that is 2L plus 42 divided by L. Well, instead of writing the L in the denominator, I can't use the power rule on that, so I'll have to move it up to the top, but I'll have to change the positive 1 power to a negative 1 power. So that's not, I haven't taken a derivative yet, but that's just observing that 42L to the positive 1 is the same thing as 42 times L to the negative 1. Now if I flip the 42 into the denominator, I also have to change its imaginary power of 1 here to a negative 1, and I don't want to do that. So I'm going to leave the 42 in place. I'm just moving the L to the top by changing its exponent. Okay, so that gives me, oops, this is not a prime yet. That's just the equation itself. Now I'm going to find the prime. Well, here's 2L. Subtract the power of subtract by a power of 1, and that makes it L to the 0. Plus, well, I bring down the negative 1, multiply it by the 42, and now subtract 1 from the top. So I already have L to the negative 1. I'll subtract 1. So I have 2. Now I have a minus, because I have a negative 1 times 42. I have minus 1, excuse me, minus 42 L to the negative 1 minus 1, which is negative 2. So now I have a derivative function, and now I can evaluate P prime of 6. So I basically just plug in 6 for L, and I have to raise that to the negative 2 power, so I'll let my calculator do that for me. 2 minus 42 times 6 caret negative 2, and that gives me about 0.83. So what does this mean? Well, we know that this is inches in perimeter per inch of length. So this says that if I increase, if I already have 6 inches in length, so here's my 6, if I increase that by 1 more inch to 7, then that's only going to increase my overall perimeter by 0.83 inches. And we're thinking, well, that doesn't make any sense. How could that possibly work? If you increase your length, don't you also increase your perimeter proportionally? Well, not necessarily. The reason being because if I increase the length, I also have to decrease the width. But the width doesn't decrease by 1. Perimeter is not fixed. It's the area that's fixed. So if you notice, 3 times 7 gives me 21. But if I decrease this, or even increase it to say 8, now what times 8 gives me 21? 21 divided by 8 would tell me that this would have to be 2.625. So even though I increased the length by 1, I only decreased the width by just under 0.4 inches. But the point is, we have a fixed area, and that's why we get this different change in perimeter for a change in length. In part D, we're asked, suppose the length of the book is 7 inches. How would the perimeter of the book be affected if the length were to be increased by 1 inch? Think instantaneously here. So really part D is asking the same thing as part C, except it's asking it in words, and it's saying, well, what's the instantaneous rate of change in the perimeter when the book is 7 inches in length? So now we just need to find P prime of 7, and P prime of 7 is going to be 2 minus 42 7 to the negative 2. So all I have to do is come in here and I'll pull up my equation from 2 lines ago, and I'll just change my 6 to a 7. And that gives me 1.14, or about. And now this is again inches of perimeter, inches in length. So now this is interesting, because now if I increase my length from 7 to 8, I am actually adding a lot more to the perimeter. So gosh, maybe this isn't such a good idea to go from 7 to 8 inches in length, because my perimeter is being affected by a lot more than if I went from 6 to 7 inches. So this is sort of an interesting take on the derivative and how it can be applied in situations like this.